My name is Angelina Banway, and I'll be presenting the first part of the introduction, which is regarding Hypothesis 1. And it states when conditions of an economy change, such as low to moderate inflation, it becomes good for the U.S. economy and will result in an increase in after tax personal consumption, which is also known as disposable income for the consumer, and an increase in savings for the consumer shows a positive correlation amongst each variable. So, in order to determine if we can even accept or reject the hypothesis, we had to summarize the most recent inflation rates and analyze trends, as well as having a depth analysis of the sampling of participants who actually participated in our questionnaire. So we went on to quote Ben Bernanke, who is a former chairman of the FED, and he said that moderate inflation is actually good for economic growth. When consumers expect prices to rise, they're more likely to buy now rather than wait, which actually increases demand, and that's because inflation is usually driven by expectations of inflation. So, another way inflation affects consumer spending during times of inflation is consumers typically overcalculate the actual value of their inflated revenue, and this increases their consumption according to the perception of an increase. So the results ended up basically, we calculated the means of the inflation, disposable income, and savings and assets, and we also calculated the standard error. Basically, let's move down here. After running a regression linear analysis on the data we used, SPSS gave us two different tables of data, which is ANOVA and the coefficients. So since we use continuous data on both our independent and dependent variables, the tables will be our T and F test statistical data outputs. So moving on to part D, which was for hypothesis 1. Our under standardized constant is good as a positive value. Let's see.
Alrighty, so my name is Daniel Lee. I'm going to be talking to you about hypothesis 2, its introduction, the actual hypothesis, hypothesis testing, and of course, our conclusion on the data. So let's start by talking about hypothesis number 2. It says, individuals that are less concerned with job security and inflation are more likely to be concerned with their level of income. We go on to use the introduction here to capture the reader's attention so that they're interested in the hypothesis. Use the 3 in 10 article by LinkedIn to show that 30% of today's jobs account for self-employment. We also use U.S. workers' job loss fears back to the pre-recession level when job security was actually very high thanks to corporations today. It's similar to that level back then. 34% say it's not too likely, and a majority of 52% say it's not at all likely to happen. We go on to introduce the hypothesis once again, and then we go on to prove it. We quote former U.S. Labor Secretary Robert Reich. Wages are stuck because people are afraid to ask for a raise. They are afraid they may lose their job. This statement here pretty much sums up the article written by Daniel Aronson and Daniel Sullivan on decline in job security to decline in wage growth. And we have that link right here, along with the entire publication. Next, we talk that when a worker focuses on one thing, they can't focus on another thing, meaning they can only focus on one thing at a time. And this is important because we don't want our variables to have separate or positive correlation. We want them to have negative correlation in order for our hypothesis to be true. And having a positive correlation will be the null hypothesis. So next up, we talk about how 40% of all jobs in the US are contracts. But even then, these contracts have very high job security as well. Then we continue to talk about inflation, how inflation is high, and the reason being is because of the middle class families not caring as much about inflation, but caring more about how to pay for their middle class securities. We talked about this earlier in the introduction, and here is the article to support it, giving different and various graphs about middle class security, how much they pay, and the real output that they're making versus real compensation. As we take a closer look at the data that was just described in these articles, we can see that the negative correlation between job security and income level, and the negative correlation between inflation and income level. Then we go on to actually test this. So we're going to go into the charts for our testing, and I'll explain to you what they mean. So here we have our descriptive analysis. First of all, we're going to talk about our statistical means. For job security, we have 24.9. Inflation came out to about 10.58. And income came out to be 40.04. We also calculated the standard error, which came out to the following. Job security at 1.363, inflation at 0.671, and income at 1.445. We took this data and we plugged it into the formula for our confidence interval range, which is basically taking the mean, statistical mean, and plus or minus 2 as the approximation that we were told to use instead of 1.96 or whichever other variable we can come up with, and we multiply that by our standard error. So first of all, we multiplied 2 by our standard error. And for job security, we get 2.726. For inflation, we get 2.89. And for income confidence interval, we came out to 1.342. From this, we apply the formula, and our ranges came out to about 22.174 to 27.626. Income came out to 37.15 to 42.93, and inflation came out to 9.238 to 11.92. And you can see the numbers are pretty close to the original ones, which is what we want. So inflation from 9 to 11, income from 37 to 42, and job security from 22 to 27. So after we ran the descriptive statistics, we went and ran the regression linear analysis on the data, using job security, inflation, and income, of course. And SPS gives us two different tables. They give us our chart A, the ANOVA A, and the coefficients table. So first we'll talk about the ANOVA A. We used the regression linear analysis because our independent and dependent variables are continuous and without groupings. The ANOVA has 1, 2, 3, 4, 5 columns. The sum of squares, the DF, the mean square, the F, and the significance value. We're going to talk about 4 of them. So first of all, you can see the sum of squares comes out to about 71,000, which sums up the regression and residual. Our DF, which is our degrees of freedom, ends up at 184, which is perfect because it states n minus 1, so 185 total, which is what we had for the experiment. And then we have our mean square, as well as our residual. And our F came out to 93.519. And what's the most important here is our significance level, which came out to be 0.000. So from this, From this test alone, we can see, because of the significance level, that we could technically here reject the null hypothesis, which is basically the fit of the intercept-only model and our model are equal. In this case, they're not. However, we're going to double check this by going through the coefficients table, which has the t-test, as well as look at a histogram. So if we look closely at the coefficients table, we can see here the unstandardized B column comes out to about 68 for the constant, negative 0.77 for job security, and negative 0.875 for inflation. This is really good here because what this tells us is that for every 1 point that goes up in income, job security goes down because it's a negative 0.77. And likewise for inflation. If income level goes up 1 point, then inflation goes down negative 0.875. From this alone, we can tell that there is a negative relationship going on between our independent and dependent variables. So next we're going to move on. We're going to look at the t-value here. Our t-value is 28.338, and the job security is negative 13, and inflation is negative 7. So in order to make any decision based on just this data here, we don't have enough. So we're going to look at the significance value because this one really tells us if we fall into that 95% confidence interval. So obviously you can see that they are all 0.000. That's a good thing. That means that we can, at this point, reject the null hypothesis. Here we have the extra parts, like the 95% for the lower bound and upper bound, and also correlations with the zero order, the partial, and the part. We also have the beta here, which has a negative value, and we have the standard error. So next we want to look at the histogram. To just double check, we already can tell that there is a negative relationship based on the constants. And since all our significance values come out to 0.00, we can definitely say that there is a relationship between A and B, and that we can reject the null hypothesis, which states that there isn't. So we're going to take a look at this histogram here, just to double check us. And as you can see, we have the regression line here. And the data pretty much follows the line completely. We don't see too many outliers. I mean, there's one up here and there's one over here, but they're not too far from the line. They pretty much stay in line. And that's a good thing. That's what we want to see out of the 185 tests. This basically just tells us that we don't have anything that could be throwing off our data tests or making our data look good when in reality it's not. And this is just a good way to check to make sure our data came out correctly. So based on these, we can conclude, as we stated in our conclusion in the paper, that because of the constants and the significance values, we can reject the null hypothesis and conclude that there is a negative relationship based on the constants between job security and income and inflation and income. Now, as we stated up here, we did 3 tests, but we didn't test for the opposite, which is when income goes down, job security and inflation go up. And that's the one part that we would like to hopefully be able to test next time. And definitely would like to make more sense of the data Obviously, there were some we didn't cover, like the beta, but for a majority of the part, we covered the t-test, the f-test, their significant values, the means, we covered the ranges, and just from the test alone, we can conclude that there is a correlation, and we can reject the null hypothesis, and we can see the negative correlation from our constants. Thank you.